Hello everybody and welcome back to the multiplayer project, where we have quite a bit to do today. I realize I've been doing this a lot, but client input to command interpretation, that's not going to happen right now. And we're just going to put that right there. And latency compensation and interpolation, well, interpolation is going to happen in the next episode, and latency compensation, we're going to bump that down to coming soon. So for right now, we're just going to do seeing our motion from Gamestate updates. And also, don't forget to fix entity 2 UDP message and the bug in chat box. Let's do those right now. I just marked that down so that I wouldn't forget, because that's just a couple of minor things that we need to do. So we need to go to our chat box, which is in here. There we go. And I found a bug with the on submit chat. If we don't have anything in there when we close it, then it puts out an error because there's nothing in chat input.text position 0. So we just need to check for that really quickly. That is not much of a problem, really. So we are going to do that right now. We'll just get that scratched off of the list. If chat input.text .length equals 0, then we can just say no parsing to be done, and we can just do on end chat input and return. Okay, so there's that bug fixed. We'll scratch that off of our to-do list, and I'm actually just going to pin the to-do list over here so I don't have to look for it occasionally. We'll just get that out of there. Wonderful. Now, one thing that is going to happen in this episode is something that is up in here, I believe. Maybe it isn't, now that I think about it, actually. But it is something that we have talked about, and that is that we are going to not send the whole game state every time. We'll update it periodically, about 1% of the time, and then every other time we will send just a what changed message. So we also need to fix entity 2 UDP message, and that is, I believe, in the server. Yeah, it's 2 UDP message, so that's definitely in the server. So we're going to change a lot of things with entity. And let's actually just get into this. So we're not going to change anything in the const fields. These public fields, they are pretty much all going to go away. And actually, I have my wrong reference open. I have the entity in the client open. There we go. So these are pretty much all going to go away. I'm going to rename this region to private fields. And we are, for right now, we're going to leave the others, but we're going to be replacing those very, very shortly. So we're going to go ahead and we're going to do a private static string builder SB equals new string builder. String builder. No. String builder. Visual Studio did not want to autofill that. Okay. Now, I was previously... Yeah, it wants us to... It wants us to make the field read-only, and we'll go ahead and do that. If that doesn't work, we can change it, but that should work. There shouldn't be a problem with that. And yeah, it's saying that we never use it. We absolutely will, because we're going to go down to 2 UDP message here. And we're going to get rid of SB equals new string builder. There we go. And instead, we're just going to do SB.clear. Now, we're going to have a lot of work to do in this 2 UDP message here. So we're going to basically rewrite this in total. So I'm actually not sure why I put that in the to-dos, because I did end up basically completely rewriting it. But that was earlier today, and I guess I didn't know exactly how big we were going to how big we were going to go on this particular one. So there's a couple of things that we need to do here. First, I want to set this scale equal to vector3.1 rather than 0. We'll have it just default to 1 for the scale, and that will help a lot. But we're also going to get rid of all of these fields. So let's just do that now. And we're going to be turning these into properties. We no longer need the private fields. We can minimize that. And yes, this does break everything, and that's okay. So we're going to be making some backing properties as well as some private Boolean properties here. And we're going to make just a single property first, and this is not going to compile at first. So we're going to do public bool dirty. So essentially the way this is going to work is we're going to have flags for each of these variables. And when we send it to the UDP message, we're only going to include it if we are requesting a full update or if the flag is dirty. So we're going to need a flag for all of them to indicate if any of them is dirty first. So that's what this here is, this particular property, and we're going to do a get, and as well, we are going to do a set in this one. So in the get, all we're going to do is return, and to indicate these kind of backing variables, I'm just using an underscore and all lowercase, movement speed dirty, or underscore name dirty, or underscore position dirty, or underscore rotation dirty, or underscore scale dirty, or underscore desired position dirty. And when we add more things into the entities, like stats and abilities and things like that, those will have to be added here as well. Then in the set, obviously none of these exist yet, they will exist. In the set, we are going to do underscore movement speed dirty equals value. So essentially, we're going to go through all of these and we're going to set them equal to the value of dirty. So when we set this to true, it sets all of these to being dirty. If we set it to false, it sets all of these to not being dirty. Just so that we can do it a little bit more quickly. And then we're going to do name dirty equals value. We're also going to do underscore position dirty equals value. Like that. And then underscore scale dirty equals value. And also underscore desired position equals value. And I feel like I'm forgetting one. I am. Underscore rotation dirty equals value. Excellent. Okay, so we can go ahead and minimize that. We are done with that property. For now, anyway. So the next one that we're going to want to do is going to be our movement speed, I think. And for that, we're just going to do a private float underscore movement speed equals 1.0f. And this is just going to be the backing variable, and we're going to be primarily interacting with the property. And then we're going to have a private bool underscore movement speed dirty, 2Ds, dirty equals true. We're going to have this all be true at first. Because this is new, and we haven't sent it yet, right? So everything is going to be dirty here. And then we're going to do public float. This is the actual property, so a capital M, movement speed with a capital S as well. And then all we're going to do in here, these are going to be pretty simple. Get will just return underscore movement speed. And when we set these, we're going to set underscore movement speed equals value. And we're also going to set underscore movement speed dirty equal to true. Excellent. And that's all we need to do for basically all of these. I'm actually just going to copy this. And we can minimize that. Then we can paste this in. And we can change this to be underscore name. This will, of course, be a string. And then we're going to declare underscore name dirty equals true. Public string. This is going to just be name. Excellent. And then we're going to return, of course, underscore name. And we're going to, down here, set underscore name to true and name name to value and name dirty to true. Excellent. So we'll copy that again. And we need to do the same thing for position now. So this is a vector 3. This is going to be underscore position. This is going to be private bool position dirty equals true. And then this is position. We're going to return underscore position. And our underscore position in the set will be equal to value. and then underscore position dirty equals true. Excellent. Why is this giving us an error? Oh, because it's still a string. This needs to be a vector3 position. There we go. And in fact, no, I don't want to do that. Let's put the 3 back there. Let's just copy this like this, because all of our future ones are going to be vector 3s. So there we go. We'll declare position, or we already declared position up here. So then we'll next do vector3 rotation, if I can type, which we've already established that I can't. Rotation dirty equals true. This is going to be rotation. This is going to be returning underscore rotation. Underscore rotation equals value. And underscore rotation dirty equals true. Wonderful. Now we need to do the same thing again for scale. So vector3 scale, actually lowercase scale, there we go. This one will be scale dirty. This one will be, of course, scale. And then we'll return underscore scale as expected. And then when we set, we'll set underscore scale equal to value. And also, we'll set scale dirty equal to true. Excellent. And we need one more. We need our desired position. So we'll now do desired position here, underscore desired position dirty. And one of the major reasons why we are changing all of these names is so that we have these compiler errors, so that we have to change this and make sure it all works correctly. We'll return desired position in our getter, and in our setter, we will of course set desired position equal to value, and desired position dirty equal to true. Wonderful. Okay, so we can go ahead and minimize all of these properties. We do not need them anymore, assuming I didn't introduce any bugs. And we are going to need to change desired direction here, so that'll be a capital D on desired position minus a capital P on position, and the same thing here. So there's 4 of those compiler errors done. We'll go ahead and minimize that, and we'll set our constructor over here to be capital N, capital P, capital R, capital S, and capital D. That brings us down to a mere 25 compile errors. Wonderful. On tick, we're going to need to do the same thing. We'll set this to a capital P, to a capital D. This will be a capital D and a capital P, as well as a capital P and a capital P over here as well, and a capital D, and a capital M, and a capital M, and a capital M. That brings us down to 15, and now we get to toUDP message. And this, we're going to pretty heavily overhaul. First, let's go ahead and create ourselves a helper method to deal with this vector3 to string. There is a built-in toString, but it uses caret brackets, like it uses these symbols. And I don't want to do that, so let's just make our own quick here. So public string v3 to string vector3 v3. And we will return string.format, and we're basically just doing the same thing we do here, just to clean this up a little bit. And this will be formatting this as in parentheses 0, 1, 2. So exactly the same as we've done up here. And then this will just be v3.x.toString, and then we'll do the same formatting as we did previously. 0.00. v3.y.toString. This would then, of course, be the same if I can... There we go. Typing is very difficult with the microphone in front of me, apparently. 0.00, and then v3.z.toString, and this would, of course, be 0.00, and then a closing quote. Wonderful. Okay, so that gets us our vector3 a little bit more cleanly than this, and I'm actually going to just delete everything here, and we'll redo it. So the first thing that we need to do before our clear here is we need to do if not full update, which doesn't exist yet. We'll go ahead and put that in here. We're now taking in a bool on this toUDP message, bool full update, but it will default to false. So if we're not full updating and we're not dirty, then we have nothing to be updated, and we will simply return an empty string. We'll check for that in the instance in a moment. Next, we need to do sb.clear, which we already are actually. We're doing that right here. And then after the clear, we'll do sb.append, and we're going to append in entity, and then with a curly brace, entity name equals, and then we'll sb.append name, and then we'll also do sb.append a comma. Now previously, we put that comma in on the next line with one fewer append, but with this current system, there might not actually be anything else other than that entity name. And realistically, now that I think about it, the entity name could be dirty as well. So we need to just put in entity here. So we'll just put in entity, and then here is where we'll start this. So if full update or underscore name dirty, then we will do sb.append, and we will append in entity name equals, and then we'll also append in the name and the comma. And this is going to be our format for how we're going to append basically everything here. But before we do all of that, I want to check to see if we end in a comma, and if so, delete it. So to do that, we'll just do if sb.toString ends with a comma. If we end with a comma, we don't want to do that. Then we want to do sb.remove sb.length -1 1. So that'll just remove the last character from the string builder if it's a comma, and then we'll append on the closing curly brace after that. So right now this will obviously only put in the name, but it's basically exactly the same thing for the others. So I'm just going to copy this, and we'll do, instead of name here, this would then be underscore movement speed dirty, and of course this would then be changed to movement speed equals, and then we just append in movement speed dot toString in our 2 decimal point format. We don't care about precision any more than that. Excellent. We can now copy that in again, and the next one that we're going to do is our position. Position dirty, and then if our position is dirty, then we can do position equals. And then here we're going to use our new helper method that we made down here. It's going to be v3 toString, and then we're just going to pass in position. That's all we got to do here. Wonderful. And we're actually going to copy this one now because all of our remaining ones are vector 3s. So this will, of course, instead of being position, be rotation. And then we'll change that here as well. And then this would be passing in rotation. Excellent. And then our next one will, of course, be scale. So we'll check if our scale is dirty. Then we will append scale equals the scale. And finally, our desired position. If our desired position is dirty, then we're going to want to do desired position equals, and then also desired position. Wonderful. And then, once we are done with all of this, once we've done toUDP message, we want to make sure that it knows that we've transmitted this and it's no longer dirty, right? But we don't necessarily know if we're just calling toUDP message that it's been transmitted. So let's actually do that in the instance here, right before it actually sends that. So it would do that right around here. Let me just hop over here. There's a couple of things that we need to do for the instance. Overall, we want to put in another private variable here, private int state count equals 0. Wonderful. And then in the get state update, we're going to want to do bool full update equals false. If state count is greater than or equal to 99, then state count equals 0 and full update equals true. So that'll just make it so that every 100 times that this goes around, it'll send a full update rather than just a partial update. So in theory, it'll be sending that, let's see, it sends it, what, 10 times per second? So 10 seconds. I mean, if you miss one of those full updates, that's going to be a bit rough. But we can change this state count here. In fact, let's go ahead and do a region const fields and region. And we will say public int full update frequency equals 99 for right now. And then we'll just say here, instead of hard coding this at 99, we'll do full update frequency. So we can just change that whenever we want to. And this, of course, needs to be a public const int full update frequency. There we go. It's assigned, but its value is never used. Yeah, not yet. So we are doing partial updates now. So we will get rid of that to-do there, which really should have been put into the to-dos, realistically. Okay, so now we need to pass in over here to UDP message full update so that it knows whether it should be getting a full update or not. However, we shouldn't really be doing that here anymore. So let's go ahead and take that out of here. And let's see, I'm just trying to figure out where exactly I ended up doing this. Oh, right. I stopped sending the instance ID. We don't need that, so we can get rid of all of that and bring this down to here. That's what it was. That's what was tripping me up. Okay, so now we need to go ahead and put in a string entity equals. This will be entities I dot to UDP message. And we'll send whether we should full update or not. Then we'll check to see if entity equals an empty string. Then we can know for a fact nothing to append here since nothing's dirty. And we'll just continue. And that'll just continue with the for loop on the next iteration. Otherwise, we want to go ahead and append. We don't need to rebuild the message, of course, because we saved it. So we'll just append entity at that point. And right here, we should also, we know for a fact that we're going to be sending it from here, right? We know that we're building that into our state update, and that's going to be sent. So from here, let's go ahead and set that dirty flag. So entities I dot dirty equals false. And that'll just set all of those dirty flags to false for us. Wonderful. Otherwise, we are almost done. We still need to do a state count ++ right here. And I don't think, no, I did not change anything in tick, so otherwise, that's good on the server side, I think. Did I change anything in server? I did change a couple of things because there are a couple of compile errors that we're going to have. Now there's 2 in entity. I missed a parenthesis here. Easy enough to fix. And this can't convert this to a vector3 because this needs to be desired position dirty. That was just a typo on my part. Now server, I believe, should be having an issue. Yes, indeed. Because we don't have a desired position. We just need to set that capsed like that. Okay, let's run this and see if this compiles. It looks like it does. Okay, no compiler errors. That is fantastic. So let's hop over to the client now, because we need to be interpreting this. But before we do, I want to do a little bit of work here. We're going to create an empty, and we're going to call this camera target. We will set that to 0, 0, 0. There we go. And we're going to put this right up here below the UI manager, and we'll set the main camera as a child of that. We'll set the main camera back 15 units on the Z-axis, but no units away on the others, and then we'll just rotate the camera target 50 degrees to get us a kind of pseudo-isometric perspective, which is what I'm going for this. Okay, so obviously we're supposed to see our motion from game state updates, but what we did so far is building variable game state updates, right? So if we were to run this right now, we would see that, let's see, this is not the server at all. I always do that. Let's fire up the server here. If we were to run this, we would see that we should be receiving game state updates that only send us what we need to know, as in what has changed. So yeah, you can see here, we're receiving an empty game state update currently. We received a single game state update with all of this full information. And once this reaches 100, yep, that ticks up to 2 because we have now received a second one of these. And if we were to do /move 1, 2, 3, we'll see our position starts moving, and that's the only thing it's telling us. Actually, that's not sending in what entity name there is. Right, because I changed that. We want to send in the entity name every time, because that's how we're identifying this. Good thing I caught that. That could have confused me. So we want to send this name every time. That is what we were doing previously, but I'm just making it a little bit more flexible here, I guess. We can change that later on if need be. Okay, so it's sending us variable updates. That's great and all, but if we go into our net manager here, what do we do with that? Well, we just debug log it. That's not exactly super useful, so instead, let's do something actually useful with it. And what are we going to do with it that's actually useful? Well, let me pull open our net manager here so that I can see how exactly I implemented this. Okay, so we actually don't need this method. We're not going to parse it here. We're just going to pass that message straight over. So this is a GMS message, and all we're going to do here is add job. And we're going to add this job over here. Excellent. We need to add this because we're going to be instantiating and doing things within Unity with the representation manager, much like we are with the UI manager. So this needs to be done on the main thread. And we're going to do representation manager, although we don't currently know about it. We'll have to tell the net manager about this. Update game state content. Excellent. Now the net manager needs to know about this, so we'll head up to our references. Public, this is going to be representation manager, representation manager. And of course, representation manager does not currently have a update game state method. And it is open. I was going to say it does not appear to be open, but it absolutely is. We're going to have to change a few things in the representation manager. We're going to change this to a public entity prefab. We're also going to change this from a list of entities to a dictionary of string entity, so that we can just look up the entities much faster based on their entity name. We still need those parentheses. There we go. Okay, so this is a relatively complex parse that we need to do here, but we already handily have most of the parsing done in entity.cs here, where it automatically determines all of this. But I want to simplify this a little bit before we get into the update game state. So, first thing first is when we do from UDP message here, if we receive an entity update that's not valid, I want to see it. So we'll do debug.log message. And actually, we'll do log error message. And we'll just flip these around, change this like this, so that reads in the log just slightly better. Okay, now this is all going to remain largely the same. When we are down here, we no longer need our array of coordinates because we're going to simplify this a little bit. We're going to do that down here with a new method, public vector3 v3 from string v3. I don't know if there's a built-in Unity method for this, like vector3.parse. No, that doesn't seem to exist. But we'll just do v3 from string here, and this is expecting in the format of x.xx, y.yy, z.zz. Okay, so we're going to declare vector3 ret equals vector3.0, and we'll return ret. And then in the middle here, we'll need to do a couple of things. First off, we'll need to trim off these parentheses, which we'll do with v3 equals v3.trim, and then we're just going to trim off the opening parenthesis as well as the closing parenthesis. Then we're going to do string coordinates equals v3.split, and we'll split that along comma lines. And then we'll do ret.x equals float.parse coordinates 0. Ret.y equals float.parse coordinates 1. And ret.z equals float.parse coordinates, not coroutine, coordinates 2. Excellent. So that gets us our vector3 there. Nice. Now all we have to do up here is get rid of everything here, and everything here, and all of this, as well as all of this. And let's go ahead and say transform.rotation equals quaternion.Euler, and then we'll do, let's see here, rotation. And then we'll need to parse these out, of course, so we'll need a little bit of space in each of those locations, and this will simply be position equals v3 from string, com1. Excellent. And it's going to be the same thing for rotation, except, of course, that we're going to be doing rotation equals v3 from string, and the same thing down here, scale equals v3 from string, and the same thing here. I really shouldn't have gotten that line break, but whatever. Desired position equals v3 from string. Excellent. So that'll get us our entity update, and this is flexible already, so it'll only update things that it is passed. Wonderful. So the next thing that we need to do, of course, is in the representation manager, we need to put in our public void update game state. And this is going to take in a string game state. Okay, so this is currently in this format. And I'm just going to copy this in from the other project because I do not feel like typing that all out. So it's in game state, entity, entity name, blah, 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 blah. Some of these things may or may not be here. Note the double curly braces at the end, and just that's all that stuff. The client doesn't care about the instance ID, which was why we removed that from the game state update. That's just information we don't need to send. So first, let's check to make sure this is a game state. If gamestate.substring from position 0 to 10 is not equal to gamestate curly brace, then this isn't a game state message, ... debug.log error game state. And we'll also debug.log error. This will be representation manager dot update. Wow, update game state received an invalid game state update. Okay, and then we'll just return. Wonderful. If gamestate.length is less than or equal to 12. And this number is this plus 1 plus 1 for the closing brace plus 1 extra for good measure, I guess. This is an empty game state. Nothing has changed, so let's do nothing. We'll just return. There's no need to say anything about it. We expect to receive empty game states from time to time. In fact, we expect, at least right now, that most of our game states will be empty game states. So we should definitely support that. Next, we should remove the header and trailing single curly brace, since entity expects 1. Okay, so game state equals game state dot substring, and we're just going to take from position 10 to game state dot length minus 11. And that gives us our header and our curly brace in the 11. Wonderful. And actually, I'm going to make this be less than or equal to 11. So we'll remove that, and that gives us our game state in this format. So actually, let's do this. Let's split this by, and then in quotes here, entity, like that. So this would be an array of strings, entity strings equals game state dot split. We'll do this with a new string, and that string array, of course, is just going to be the 1. Have to do it in an array, sadly. I wish we didn't, but new entity, and then we would do system.string_split_options.remove empty entries. We don't expect empty entries, but we'll see. Maybe there are some. If so, this could potentially cause issues, but we don't expect that. So that gives us this, and I'm just pasting this in from the other project because I don't want to type this all out. That gives us this sort of message here, where we have a full entity on the first instance of an entity here, but other entities are missing this header. Okay, so we'll need to iterate through this. For int I equals 0, I is less than entity strings dot length I++. We will then say, first, let's parse out the name to compare it to what we have. So we'll say int first comma equals entity strings I dot index of, and this is going to be a comma. Then int equals entity strings I dot index of equals. So that gives us the position of this comma or this comma, depending on whether we're on the first entity or any after, and also our first equal sign here or here. Excellent. And then we can simply say string entity name equals entity strings I dot substring, and then we'll grab from equals plus 1, because we don't want to have the equals in here, to the first comma minus equals minus 1, because we don't want to contain the comma. And of course, the reason we have to subtract out equals here is because this is a length, not an end index. Excellent. So that gets us our entity name. Now let's put the header back in, but only if it's not the first entity, because the first entity still has the header, right? So let's go ahead and say if I is not equal to 0, entity strings I equals string.format, and we'll just put in entity, 3 curly braces, because we have to put double curly braces to escape those, 0, and then a single curly brace there, and then entity strings I. Need another parenthesis, I think. No, we won't. There we go. Excellent. So we've got our entity back in here, and now we need to figure out what entity we end up passing this to call from UDP message, right? We need to determine, is this a new entity that we don't know about and we need to spawn one? Or is this an entity that we do know about that we need to update? So we need to take a look at that. So first thing that we need to do here, of course, is we need to see if this entity already exists. And this is the reason for why we switched over to a dictionary, because we can run this check way faster with a dictionary than we can with a list. So we're going to do if entities dot contains key, and this would be entity name. If it already exists, it does, so let's just update it. Excellent. We'll do entities, entity name, dot from UDP message, and we'll now just pass in entity strings I. Wonderful. Otherwise, we don't know about this entity yet. We'll need to spawn one in. So we'll say entity equals instantiate entity prefab vector3.0 for its position, quaternion.identity for its rotation, because we're just going to spawn it in completely default, and this way we don't have to worry about, oh, is our prefab in the wrong place? What about, we can assume that it's going to be at 0 in identity. It's just a little cleaner, I think. And then we'll pass in this.transform as its parent, because we want this to all be parented to the representation manager just for cleanliness sake. Next, we'll need to say entity.fromUDP message, and we'll pass in entity strings I, and we'll parse that out. And we'll need to record it in the dictionary. So entities dot add, and then we will add in entity name as the key and entity as the value. Wonderful. Now keep in mind, these entities aren't just like players. They aren't just players and enemies. They're basically everything that matters in the game. Players, enemies, projectiles, pretty much everything. Like delayed ground effects, everything will be a subclass of entity. So excellent. There we go. Now, I believe we need to tell the net manager about the entity. So let's go ahead and do that. Or rather, tell the net manager about the representation manager. The representation manager is going to need to know about the entity prefab, which we can do like so. And then the entity here is not set to 000. It will get set to that when it's spawned, but I'll just change it just for my own peace of mind. Okay. So there we go. I think that will do the trick, but there's a lot of little things that I have to remember, and I probably forgot something. So let's test this and see how this works. We'll fire up the server. No compiler errors. We'll fire up the client. We'll wait for that sweet, sweet encryption handshake, which didn't take long this time. We'll log in. It spawned our entity. And if we pause this, you can see if we go into our representation manager, here's our entity here. And this is ASDF, movement speed of 1. Scale is, of course, at its default of vector3.1, because that's what the server told it to be at. And now we'll do /move 1, 2, 3. And you'll notice, assuming that this works, you'll notice that we move in a pretty jittery way. And the reason for that is because we are only receiving 10 updates from the server per second, And our game is currently running at 800 to 1000 FPS. It's going to look jittery. So let's go ahead and run this and hope that this all works out. Hey! So yeah, you can tell here, this is quite jittery. We'll do /move back to 0, 0, 0 at this point. Yeah, that's definitely at a low frame rate, and you can tell that. But that's okay, because next up is going to be interpolation. So let's hop over into here, into our to-dos. Seeing our motion from Gamestate updates is done, and as a corollary, we're also sending much more economical Gamestate updates. Rather than sending the whole thing 10 times per second, we're sending it once every, currently 10 seconds. I might reevaluate that, but we're sending the whole thing once every 10 seconds and then only updates 10 times per second. So yeah, after next, our next episode, we're going to work on interpolation, and there might be some client input and command interpretation there, so we don't have to use the command line interface, because that would be kind of nice. That would be a very nice thing to have. Latency compensation is a bit of a complicated one, and I'm probably going to avoid doing that as long as possible, but that is definitely something that we're going to need to do pretty soon, because we are starting to get relatively close to having a functional game here. In which you can do nothing, but we're getting close. For now, though, I'm going to go ahead and put a cut in here, and as I said, next episode, we're going to work on interpolation. Until then, you can leave your offerings to the engagement gods in the form of likes, comments, subscribes, and bell ringings, and I'll see you all next time.